So in this section, we're going to learn how to solve a quadratic equation using the quadratic formula, which is x equals negative b, or opposite b, plus or minus, we'll talk about this part in a minute, the square root of b squared minus 4ac, all of that over 2a. The quadratic formula is a good method for solving quadratic equations because it will always work regardless of what type of polynomial you have. For example, sometimes a trinomial isn't factorable, and in that case you'd either have to solve using the quadratic formula or by graphing, but this is the one that you can use all the time. So if we were to try to solve first by factoring, for example on number 1, I noticed that this is the difference of two squares, so it's in that form a squared minus b squared, which means it's going to factor into a plus b times a minus b. And so if I apply that to number 1, this would factor into 5x plus 9 times 5x minus 9. And then since that equals 0, I would try to get my first quantity to equal 0, in which case that would be negative 9/5, because I would first subtract 9 from both sides and then divide by 5. And my second quantity is 5x minus 9. And so to solve this would give me a root or a solution of positive 9/5, since my first step to moving the minus 9 over would be to add it. On number 2, I'm going to factor this using a traditional trinomial pattern. My coefficient of x squared is 1, so that means all I have to do is find the two numbers that multiply to get negative 5 that add to negative 4, and so that would be negative 5 and positive 1, which would give me two roots of positive 5 and negative 1. And then for my last one, the first thing I notice is that it has a GCF, so I'm going to take out my GCF of 2, making sure to rewrite my new trinomial inside. A lot of people have been skipping this step, but then it's hard for your brain to process these numbers because you're going to be staring at these numbers. So it's important to do that middle step and to not overlook it. Now I'm trying to factor what's inside the parentheses using traditional factoring. So I would like to find the factors of negative 7 that add to negative 4. And unfortunately, the only numbers that I can think of that multiply to get negative 7 are 7 and negative 1, or negative 7 and positive 1. And so in this case, what would happen is I would find that this, in fact, is not factorable, or it's not solved. Since it's not factorable, I can't solve it by factoring. And so then I would either have to graph it, or I would have to use the quadratic formula. And so that's why we're learning the quadratic formula. So we've already talked about it a few times, but the quadratic formula it's a lot more simple than it looks, I promise. So in order to find your roots, you're going to do the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And we also talked about how this part looks familiar because that's where we found our axis of symmetry. So first thing we want to do when solving using the quadratic formula is we want to be as organized as possible. So I want to identify a, b, and c. So remember, a is always my coefficient of the x squared term. So in this case, that would be 3. My b is always my coefficient of x, and so in this case, that would be 5. And c is always my constant that doesn't have an x term, so in this case, that would be negative 8. So by identifying those, I've kind of set myself up for success. Next thing I'm going to do is I'm going to write the formula. And the reason I want to keep writing it rather than just plugging it in is because by writing it down, it's going to help me memorize it. You can even sing it to Pop Goes the Weasel. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. American Idol, here I come. So the first thing I notice in my formula is that I have b, but it's the opposite. So since b is 5, then the opposite of b, or negative b, would be negative 5. Then I have my plus or minus square root of, then I'm going to have b squared. So in this case, I have 5 squared. Then I have minus 4, and then I want to replace a times c. So for a, I've got 3, and for c, I've got negative 8. And then all of that is going to be over 2 times a, which is 3. So now I'm going to start to do this out. So I'm going to treat my square root symbol almost like a grouping symbol, like parentheses, and so I'm going to do what's inside that first. So I'm going to bring down my x equals -5 plus or minus the square root. Now in here, I've got a lot going on. I've got exponents, so I'm definitely going to do that first. Then I've also got subtraction. And then the next thing I have inside the parentheses is multiplication of these three items. Now keep in mind that this minus sign, the subtraction sign, I've already included in my answer. So for right now, I'm kind of drawing a line here and only focusing on this as a 4, a 3, and a -8. I understand that this negative is attached to the 4, but I've kind of already included it here. So 4 times 3 is 12. 12 times -8 is going to be -96. So again, this minus sign was this minus sign, and then my positive, negative made a negative. Then I still have all of this over, and I'm just going to make that 6. 2 times 3. So here, 2 times 3 is 6. Now inside my square root symbol, I can change this, change opposite. So I'm going to go ahead and make that plus positive. And so now I'm going to add 25 and 96, which is going to get me 121. So now I've got x equals -5 plus or minus the square root of 121, all of that over 6. Now the square root of 121 is 11. And the reason this is plus or minus is because, remember, all numbers have two square roots. They have a positive version and a negative version. So I'm going to write this as x equals -5 plus or minus 11, all over 6. And so now I basically have two math problems to do to get my two roots. I'm going to do -5 plus 11 divided by 6. And then I'm also going to do -5 minus 11 divided by 6. So for the first one, I've got -5 plus 11 over 6. That's going to be 6 over 6. So my first root is going to be x equals 1. Starting to run out of room here, so I'm going to write it up here. And then for my second root, I'm going to do x equals -5 minus 11 divided by 6, which is going to be -16 over 6, which I could reduce to -8 thirds. So my second root is -8 thirds. You could change that to a mixed number, but there's really no need to. You could also make that a decimal. Decimals are commonly accepted answers when it comes to quadratic equation roots. However, I find that if it's a simplified fraction, I think that's always the best way to go. So let's look at example 2. On example 2, one thing to notice is that it doesn't equal 0 yet. So before I begin, I have to make that quadratic equation equal 0 by subtracting 9 from both sides. So I've got 2x squared plus 7x minus 9. Now that it equals 0, I'm ready to identify my items. So my a value would be 2. My b value would be 7. And my c value, again, would be this -9. So it's a negative number again. I'm going to write my formula. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. And I'm going to start to plug in my items. So I'm just going to come over here so I have more room. -b would be -7 plus or minus the square root of 7 squared minus 4 times 2 times -9. All of that over 2 times 2. So now we can start to simplify a little bit. -7 plus or minus the square root of 7 squared is 49. Now another little shortcut you might use is that you've got a negative and a negative, and so right away you might decide, well, that's going to become two negatives are going to make a positive, so I just changed like minus a negative plus a positive. I know this technically isn't minusing just 9, but it's minusing this product, which is going to be a negative, and so two negatives are going to make a positive. So I can make that plus, and now I can do 4 times 2 is 8. 8 times 9 would be 72. And all of that is going to be over 4. So now I've got -7 plus or minus the square root of 2 plus 9 is 11. Carry the 1. Again, I've got 121. So clearly the first couple we're just making so the numbers inside are square rootable. So now I'm going to do the square root of 121, which is going to be -7 plus or minus 11 over 4. And so your first root you'll find by doing negative 7 plus 11 over 4, which would be 4 over 4 for a root of 1. And then the next one would be negative 7 minus 11 over 4, negative 18 fourths, which would be negative 9 over 2. So again, even though I could make that a decimal, I try to avoid decimals at all costs. So my two roots here are 1 and negative 9 over 2. One just interesting thing is if you get roots that are either integers, so positive or negative numbers, or fractions, that actually would mean that these trinomials were factorable at some point. We're just choosing to use the quadratic formula to solve them. Okay, so at this point, what I want you to do is pause the video and try examples 1, 2, and 3. Remember that before you're ready to use the quadratic formula, you have to make it equal 0. And you're also going to want to make sure that your trinomial or your polynomial is written from highest to lowest exponent for identifying A, B, and C. So pause the video, press play when you're ready to check your answers. So on example 1, we're going to move 16 over by adding it. That means my A value is 1, my B value is negative 8, and my C value is 16. When I plug the b squared minus 4ac, I end up with 64 minus 64, which is 0. The only square root of 0 is 0. And when I do 8 plus 0 or 8 minus 0, I'm going to get 8. So this is a situation where I only have one root or solution. And what that would look like on a graph is it would kind of look like when your parabola only touches your x-axis once. So your one root would be right here. Rather than crossing it twice, it only crosses it once. And it also happens to be the axis of symmetry because it's the opposite b over 2a. On example 2, first we're going to make it equal 0 by subtracting x from both sides, but remember to make it go x squared, so ax squared, bx, and then c. My a value was 2, my b value is negative 1, and my c value is negative 7. So opposite b would be positive 1, and then in this case I have negative 1 squared, which is 1. You can see again that I did my two negatives creating a positive. 4 times 2 is 8, times 7 was 56. So this is our first situation where we encounter a number that's not a perfect square, and this is okay to take out your calculator to do your square root and then to round. So I just happened to round to 2 decimal places. You'll often be told how many decimal places to round to. So then I did 1 plus 7.55 divided by 4 to get a root of 2.14, and then I did 1 minus 7.55 divided by 4 to get a second root of negative 1.64. And on my third example, to move 8 over, I subtracted, plugged in my information. Again, I have my minus 4ac, two negatives are creating a positive. And when I simplify inside my radical, I get 121, which has a square root of 11. Negative 5 plus 11 was 6, and 6 over 6 was 1. And then negative 5 minus 11 was negative 16, and negative 16 over 6 was negative 8/3. For examples 4, 5, and 6, I want you to check your work using the answer key before uploading to Google Classroom. So on example 7, we're looking at a time period from 1997 to 2001. So we're looking at a 30-year time period. In this quadratic function, y is standing for the number of films produced in the world, and x is standing for the number of years since 1971. So what that would mean, just for example, is if x were to equal 5, that would mean that it's been 5 years since 1971, and so that would really translate to the year 1976. The reason mathematicians do this is it's easier to work with smaller numbers, like 1, 2, 3, 4, 5, than it is to work with large numbers like 1,976. So our measurement is starting in 1971. Now in this case, we're being asked to find out when 4,200 films were produced. Since 4,200 is the number of films, and films is represented by y, that's asking us to take the 4,200 and put it in the place of y in the quadratic function. So I'm going to start by doing that. Now I'm ready to think about solving. But remember, to solve, I need to get my hero 0. So I'm going to start by subtracting 4,200 from both sides. When I do that, I'm going to get 10x squared minus 94x minus 300. Because 3,900 minus 4,200 is negative 300. Now I have no idea if this is going to be factorable or not. All I know is that the numbers are really big and I'd rather not deal with them, even though there's a GCF. So what I'm going to do is I'm going to use the quadratic formula. So x will equal 94 plus or minus the square root of 94 squared minus 4ac all over 2 times a is going to be 20. I notice right away I've got two negatives, so I can make that a positive. So I'm going to go to my calculator, and what I'm going to do is I'm going to calculate 94 squared and then plus 40 times 300. Pause your video and go ahead and do that, and let's see if you get the same number inside the square root as I do. So I got the number 20,836. Again, that was by squaring 94 and then adding 4 times 10 times 30. So now I'm going to square root that 20,836. And so I'm going to get 94 plus or minus, I can round, 144.35, all of that over 20. So now to get my two roots, I'm going to do 94 plus 144.35 divided by 20. And I'm going to do that on my calculator. And that got me 11.92. Now my second root, I'm still going to do it, but when I do 94 minus 144 divided by 20, what's going to stand out to me is that right away 94 minus the 144.35 is going to be negative. And so then this would mean it's going to be negative 2.71 years. Since x is negative and it represents years since 1971, that would mean we were going back in time. And so 2 years prior to 1971 would be the year 1969. And so that wouldn't make sense to go back in time, especially if we're only looking at this 30-year window. So the only root that makes sense in this scenario is that it has been 11.92 years since the year 1971. So I want you to imagine if you were standing in the year 1971, maybe on January 1st, and you time traveled 11.92 years into the future, you would be currently in the year 1982. Now you're also not 0.92 of the way through the year, so we might be near the end of 1982, but this isn't asking for that. It's just important to know that the calendar would still say 1982. So you're also going to give a try right now, pause the video, and try example number 8. And I'd like you to use the answer key to check your answer before uploading to Google Classroom. You're also going to complete examples 9, 10, 11, 12, 13, and 14. These two just went on the next page for me. And you're going to use the answer key to check before uploading to Google Classroom. Make sure you also keep track of any questions that you might have, and we can definitely go over these in class on Thursday.